average atomic mass. So when we're dealing with atomic mass, we're dealing with units of AMU, which is atomic mass units. So we're going to be using this instead of grams, which is the typical unit that we'll be using. But because atoms are so small, the amount of grams that it is for just a single atom is some number to the negative something, and it's just too small and too complicated to deal with. So instead, for convenience, we're going to use AMU. So now the average atomic mass of an element is a weighted average mass of the atoms in a naturally occurring sample of the element. So earlier we talked about what isotopes were. So isotopes are different elements that have different number of neutrons, which alters the mass of an atom, even though it can still be the same element. So each of these isotopes occur at a different abundance naturally. So the average atomic mass reflects both the mass and the relative abundance of the isotopes as they occur naturally in nature. So we're going to have to calculate average atomic mass for the elements. But first let's deal with a non-chemistry example, just to get the hang of it, and then we'll do a chemistry example. So you took 5 exams in the first quarter of school this year, and your teacher is creating a test average from these grades. So you may be aware of how grades come about, so you take all the grades and average them together. So in order to average, you add them all up and divide by the number that you have. So here we have 5. So we're going to do out of 100%. So you do 100 divided by 5 because you have 5 scores. That means that they're each worth 20%, which in a decimal form is 0.2. So another way that you can do averages, you can do 79 times 0.2, which is our 20% and our first test score. Then add it to 82.0 times 0.2. And if you were to continue doing this for all 5 test scores and you added them together, you would get the average. So the average for this one would be about 79.8. And that would be your average test score for the first quarter. So this is just an example using numbers and something that you're familiar with. Let's go into a chemistry example. Calculate the average atomic mass of copper given the following information. Your first isotope has a mass of 62.93 AMUs, and that's occurring 69.2% of the time. Our second isotope has a mass of 64.93 AMU, occurring 30.8% of the time. So following what we did in the previous example, we're going to want to have our mass and we want to multiply it by how often it occurs. And we have to make sure to transfer all of our percents into decimals, just by dividing it by 100, which is 69.692. And then you're going to add it to our second mass, which is 64.93 AMU, times its percentage, 308. And that's going to give us an answer of 63.53 AMU. So the average atomic mass of copper is 63.53, and that is depending on the isotopes and how often they occur. Alright, so now I have 3 more problems for you to try. You can do them on your own, see if you got the same answer that I did, and if you didn't, Try to do them again, go back over previous examples, see if you can figure it out, and if you can't, we can go over it in class. Calculate the average atomic mass of bromine. The two isotopes of bromine have atomic masses and relative abundances of 78.92 AMU, occurring at 50.69%, and 80.92 AMU, occurring at 49.31%. The answer that I got here was 79.91 AMU. Make sure you get the same answer. Alright, rubidium has two common isotopes, 85 Rb and 87 Rb. If the abundance of 85 Rb is 72.2%, and the abundance of 87 rubidium is 27.8%, what is the average atomic mass of rubidium? So the answer I got was 85.56 AMU. Make sure you get the same answer. If you don't, come in with questions. Alright, so our last example, to make sure you really understand this, is here. Uranium has three common isotopes. If the abundance of 234 uranium is 0.01%, the abundance of 235 uranium is 0.71%, and the abundance of 238 uranium is 99.28%. What is the average atomic mass of uranium? So once again, my answer is 237.93 AMU. Make sure you get the same answer. If you don't, try it again. If you still don't understand it, we can go over it together.